Good morning, welcome to the NCRIS conference. This is Richard Lucas and Peter Scarth. We've just been attending the NCRIS in South Africa and showcasing the work of AusCover TERN, and that's what I wanted to show you now.
Good morning. This work that we're about to talk about has been a collaboration between myself, Richard, Peter Bunting from the Aberystwyth University and John Armston, who's now at the University of Maryland. It's been a project that's been ongoing now since the past 8 years, and it's really grown over that time. So through this presentation we'll talk about how TERN AusCover has really facilitated the work that we've been doing in this project. To start with, we work with a large archive of data. So you can see on this slide we've got a number of super sites around Australia. TERN AusCover supports intense data collection over these sites which span a number of our Australian ecosystems. You can also see a large number of dots on this map here as well. All these dots are individual vegetation captures which have been captured by basically mostly state agencies across Australia. You can see there's a bit of competition between Queensland and the Northern Territory in terms of capturing ground cover sites, but everyone submits data into our national database, and that really helps both build confidence in the products and gets all this data together in the end. What we can do with that is build products such as this fractional cover image here. So we build these nationally over Australia, and the data that we use for this is from the United States Geological Survey, and it's calibrated and validated using the points collected by all our partners across Australia. We can then use the time series of this to jump in and build products like this persistent green product, which gives us the amount of woody vegetation over all of Australia. And it's these products here which have formed the basis for the rest of the work that we're going to talk about in this presentation.
One of those field sites is the Indian Landscape Collaborative Project, and that started in 2000. And we've had a lot of aircraft imagery, LiDAR in 2009 and 2015, and that formed the basis of many of our ideas. If we see here, we have the Indian project was pivotal in developing our understanding of radar through the NASA PAC-RIM project in 2000, and also in the need to try and get better biomass estimates on the ground, we asked people from around Australia or particularly from Queensland, to provide raw tree data, because we knew that if we were going to use these techniques to scale up to Australia, we'd actually need all that information. At the same time, in early 2000s, we worked on the KNC initiative with JAXA, and they provided us with 50-metre strip data for all of Australia. And when we first put our mosaic together, a little bit shocking, very stripy, but we worked out that it was due to rainfall. We then took the 2009 image strips where there was no rainfall across a lot of the areas when the image data were required, and we used that with the ground data to produce the first Queensland biomass map, and that was used in the JLC Global Biomass Map. Knowing that we wanted to go national, we then developed the National Biomass Library through AusCover TERN, and using mosaics from JAXA for 2009, which were the driest, we then produced the first biomass map for Australia, and that also included the fractional cover data that Peter just talked about and the ISAT data. And the products that we've been generating since there are the Australian Biomass Restoration Potential Map, and we're doing that in conjunction with Glob Biomass, which is an ESA, a European project, and then we can start to look at biomass change. So there's a lot of future in biomass mapping in Australia. The TERN Plant Biomass Library had lots of contributions from very many people, and we really thank those people for providing that data. And we did promise a biomass map back to them, and that is on its way. We have over 1 million hugs of 800,000 trees, at least tree species over 1,400, and about 15,000 plots. These were the biomass calculated for the individual tree measurements, and they were using standardized allometrics and error propagation, which was undertaken with CSIRO, Karen Poole and Stephen Roxburgh. Why do we need a biomass library? Well, apart from ecological studies in Australia, there's a large number of sensors, satellite sensors in the future years that are going to be launched specifically to estimate biomass, and you can see that in the bottom histogram, where in 2019 there's at least 5 or 6 sensors that are going to be looking at biomass specifically. Our biomass library stops in 2014, and so we decided to do something about that so that these people in the space agencies and so on can actually have biomass data all the time.
And so to do that, we built on some of the products that we'd already developed as part of TERN AusCover. We early on developed an end-to-end data collection process using Open Data Kit and connected databases at the other end. And when we go out in the field, we collect data digitally around our forest structure, calibration and validation data. What we've done here is extend this into the biomass library, and so that we can dynamically update parts of the library as we go. This allows users, some of our bigger users as well as other users out in the field, to collect data, submit it to the library, and then through the way we've set it up, we can recalculate the biomass very quickly, including those new observations.
One of the main issues that's arisen in Australia is climate change, and the possible implication of that is the significant dieback in northern Australia. So through AusCover TERN, we are currently working on a project which would actually allow us to integrate large quantities of data to understand the response of mangroves around the coast of Australia to changes. Part of that is we're collating historical field and airborne data sets and putting that on the AusCover TERN archive. We're trying to follow up with the field measurements in near real time that Peter just talked about. And these will feed into the biomass library, which will have a mangrove component. Alongside that, we've been working with the JAXA Kyoto and Carbon Initiative Global Mangrove Watch, which is producing global maps of mangroves for 2007 all the way through to 2016, and then extending back to 1996. With the Australian Geoscience Data Cube, we're using Landsat sensor data to monitor mangroves, and then that would actually contribute to the refinement of the baseline map for Australia for the Global Mangrove Watch. Where we see change, we can use CubeSat targeted observations to really monitor that changes, potentially now on a daily basis. We're also planning flights of LiDAR right across the north of Australia to provide a baseline which gives us some indication of how mangroves are structured and how that structure indicates the changes in mangroves that have occurred over time. And here we can establish whether the dieback event is a new thing or whether it's something that's happened in the past. And so we can link that with all the climate and other environmental data sets, and then that can advise policy and science.
Okay, so we've worked on all these projects within Australia, but none of it would have been possible without the collaboration within Australia, but also externally as well. You can see from this diagram here that the biomass, fractional cover, and all the image data that we get is a result of a large global collaboration. We've got ones with the Global Mangrove Watch. We've done a lot of collaborations, which is talked about with JAXA, particularly through ALOS Pulsar, with USGS Landsat, so we basically grabbed the entire archive over all of Australia. NASA JPL through ISAT data, as well as DLR for data sets like TandemX and others. There's also been a large software development process that's gone on, so all the software we use is open source. A lot of it's come from Pete Bunting up in Aberystwyth, so RSGIS lib, SPD lib, ArcSci for correction of the data. And so we've sort of built this large international collaboration and then linked it in with our Australian partners, and I think that's one of the awesome things about TERN AusCover. It's not all about biomass though, and sort of the nice thing is that we've got these products that are now interchangeable, and you can sort of mash them up into different products. So what you can see here is a map of forest structure across Australia, and that's a result of the forest height that we've calculated as part of the biomass, but also about the cover, so we can have height and cover classes across Australia. And we're looking at how we can integrate that with the National Forest Inventory. Okay, I think we're finishing both off now.
Finishing now, and so what we found, and we've seen this at ISRC, which where lots of outputs from AusCover TERN have been presented, but really the strength of interactions in Australian ecosystem science community has been recognised internationally, and the concepts are becoming increasingly adopted in research and application projects. both in Australia and worldwide. So TERN AusCover has actually become an example of best practice, and we look forward to strengthening and promoting collaborations, infrastructure and relevant science at all levels, and to working with you into the future. Have a fantastic time at the conference, and we look forward to seeing you soon.
Thank
Bye-bye.
you. Bye.